So good morning all. So it's a 10th, so 33 minutes past 10. So uh, so we are going to start our inaugural programs. So to chair this inaugural program, so I would like to call upon Dr. San Bayan. Good morning all. San Bayan, are you over there? It's a 10th.
Yes, I'm there.
So 33 minutes past 10. So I request you to proceed our inaugural program. Please. So we are going to start our inaugural program.
Good morning, everyone. I hope I am audible. Myself, Dr. Shayan Bahan, Assistant Professor, Department of Physics, Rajiv Gandhi University. Welcome you all to the first annual Physics Colloquium cum National Science Day celebration. It is a matter of immense pleasure for the Physics Department, Rajiv Gandhi University, to organize this event. I welcome all of you, our Honorable Vice Chancellor, sir, Honorable Professor, Pro Vice Chancellor, sir, Registrar, sir, and other dignitaries. I would like to welcome our chief guest, Professor Dharendrajit Singh, Manipur University, for this event, who has given his kind consent to be with us within this program. So it is basically the visionary idea of our Honorable Vice Chancellor, Sir, Professor Saket Khushwa, and Pro Vice Chancellor, Sir, Professor Amitabh Mitra, to organize such event so that the science and technology can be boosted in every part of Arunachal Pradesh. Now I request Dr. Sanjit Singh to deliver the inaugural lecture. Dr. Singh, are you there?
Yes. Am I audible now?
Yes, you're there.
Yes, there is a slightly network problems I'm passing. So anyway, so good morning, everyone present in this annual physics colloquium, National Science Day celebration. So I, on the behalf of the organizing committee of the annual physics curriculum, come the National Science Day celebration, so extend my warm welcome to all the esteemed guests, as the chief guests, our honorable Vice Chancellors of Rajiv Gandhi University, Professor Saket Kushwaha, in our inaugural programs. So despite having a very tight and busy schedules of administrative work and program, and today on this inaugural programs of so annual physics curriculums, so we have invited our pro vice chancellors of this Rajiv Gandhi University, professors Amitabh Mitra, who was very kind enough to accept our invitation. So I cordially welcome you, sir. So it's my great pleasure to welcome our registers of this university, Dr. Nabam Tadar Rikam, gracing as a guest in this inaugural program. So I heartily welcome Professor Sanjeev Kumar, Dean of Basic Science, as a guest in this inaugural programs. So on the behalf of this organizing committee, so I extend my welcome, warm welcome to Head of Department of Physics. So I would like to take these opportunities to welcome specially today's invited speaker, Sargajam Dorendro Singh, senior professors, physics department, Manipur University. So all the professors, colleagues from different departments, and all the faculties, members, my dear colleagues, friends, and all the young researcher and the participant from the North, Arunachal Pradesh and other states. So I welcome you all present here, all on the first annual physics colloquiums come National Science Day celebrations. So I welcome you all again, and and which a fruitful programs. So thank you all for your kind intentions. So over to Dr. Anbayant for a continuations of the next procedures of our program, please.
Thank you, Dr. Sanjit Singh, for this inaugural note. Now I request Professor Pradeep Kolita, Head Department of Physics, Rajiv Gandhi University, to say a few words.
Good morning to all. Honorable Vice Chancellor Professor Saket Kushwaha, respected Pro VC Professor Amitav Mitra, Register Dr. N.T. Rikam, Professor Sanjeev Kumar, Dean Faculty of Basic Science, and today's invited distinguished guest, Professor S. Dorendrajit Singh, Department of Physics, Manipur University, Dr. Sanjit Singh and Dr. Sunika, the coordinator of the annual Physics Colloquium cum National Day celebration event, the deans of faculties, HODs, faculties from the various departments of RGU, participation from different universities, colleges, research scholars, and my dear students. At the outset, I heartily welcome all of you for joining this event, annual Physics Colloquium cum National Science Day celebration in the Department of Physics, Rajiv Gandhi University. Today, I feel a very special day for Indian scientists to remember the contribution of Sir C.V. Raman for his wonderful discovery and his legacy to look forward for the better growth of scientific temper. In 1928, an Indian scientist and Sir Chandrasekhar Venkatraman discovered the phenomenon known as the Raman effect, and for his remarkable discovery, he received the Nobel Prize in 1930, and that was the first Nobel Prize for India in the field of science and technology. And every year, National Science Day is observed to celebrate this discovery. In 1986, the National Council of Science and Technology Commission Communications requested this day, that is the February 28th, be as designated as National Science Day by the Government of India. This occasion is now held in school, colleges, universities, and under science institute, engineering, medical research organizations throughout the India. This celebration honors Sir C.V. Raman exceptional contribution to research and discovery by providing hope and inspirations to future generations to pursue their dreams. Not to stop with this one, discovery in any field, but to continue seizing the nation's credit in every day, in every opportunities. The Department of Physics strongly believes that the lecture series, workshops, etc. may give the due exposure to of recent development in physics to our young students and research scholars. Keeping in view of annual physics curriculum, a lecture series has been arranged for the first time in this current year, and it will be carried forward in the subsequent years. We plan to invite distinguished speakers within the country and abroad in online offline mode each in a month throughout the year, covering a variety of promising fields. Today, we formally in launching this series with the universal lectures to be delivered by Professor Doyendrajit Singh's Department of Physics, Manipur University. I am grateful to him as he promptly accepted our invitations and encouraged us to these missions. Professor Singh will deliver the first lecture of his series based on this theme, that this year's theme, integrated approach in science and technology for sustainable futures. The lecture program is arranged in online teaching mode in view of the COVID situation. However, we will conduct the remaining lecture series in physical offline mode. I hope there will be a good interaction among the participants and speaker. The participants, mainly the students and research scholars, would get the opportunity to learn and carry forward their knowledge to enrich the scientific temper for a better growth, and these R&D activities with the directions, suggestions, and expertise from the learned research persons. And I do believe that their lectures will enlighten the audience with due expertise in the field and motivate to researchers and students. Following the invited lectures, an online quiz competition has been also arranged among the UGPG students of Arunachal Pradesh as one of the outreach programs of the department, and we hope this will create the necessary environment for a healthy growth of scientific temper. Our young students can foresee science as a potential career in their future course of time. The department is really grateful to University Authority for their keen interest and necessary help to give us the opportunity to hold this annual physics curriculum come National Science Day. Thanks to our Honorable VC, Professor Sakit Kushwaha, for his valuable suggestion and assistance to holding this event. Also, I am thankful to Pro VC, Professor Amitav Mitra, Registrar, Dr. N.T. Rikam, and the schedule. At the end, I would like to thank our Honorable VC, Pro VC, Register, all deans of the faculties, HODs, faculties of research scholars, students, and the participants for joining this event in the online platform, and hope make it is a grand success. I would also like to make a special thank to Dr. Sanjit Singh and Dr. Sonika, Assistant Professor, Joint Coordinator, for this lecture series, for coordinating and supervising all the works for the annual physics curriculum come National Day celebrations. I would also appreciate the assistance from the non-teaching staff, MSc students, and lot of thank to them. I will also thank Dr. Sen Bayan for initiating these programs. Thank you. Thank you all of you again. Over to Sen.
Thank you, Professor Pradeep Kalita, for sharing with us the brief of this program about the event, and also revising about the Sir C.V. Raman and importance of the Science Day. Now, I would like to request Professor Sanjeev Kumar, Dean, Faculty of Basic Sciences, to share his thoughts. Professor Kumar, the stage is yours.
Thank you, Dr. Sayan. A very good morning to all of you, and a wish to a happy National Science Day to all of you. Today is present here our Honorable Vice Chancellor, Professor Saket Kuswaha, Honorable Vice Chancellor, Professor Amita Mitra, our Registrar, Dr. Nabam Rikam, and HOD of the department, Professor P.K. Kalita, and all the present here, my colleagues, all teachers from the different departments, students, and ladies and gentlemen. Today, I wish, first of all, I wish to Department of Physics to success this program, and this is the starting a new lecture series in the department. And I wish to Professor Kalita and his team to success this event for all the year. Today is the National Science Day in the memory of that the innovation of Raman spectroscopy. Raman spectroscopy tell us the importance of the fundamental research. Now in these days, the people are running behind about the applied research. So Raman spectroscopy tells the importance of the applied research. When 1928, the Raman discovered this, he doesn't know about the application of the Raman spectroscopy. Now you can see the every field, every advanced science and technology, Raman spectroscopy has the very crucial role to identify the materials, identify the molecules, and scientific world today materials have gained a huge interest owing their applicability in the energy productions and storage and optoelectronics quantum devices in addition to the sensors also. Ultra thin thickness of the materials make their properties such as band structures, electron-phonon interaction, and the latest vibrations extremely sensitive to the substrate. Thickness, deposition methods, defects. Raman spectroscopy offer due to its high spatial and spectral resolutions. The latest vibrations in 2D materials is indicated by Raman peaks and exhibited the predominant features like shape, peak positions, full width and half maxima, which are useful to characterize understand the properties like phonon frequency, electronic states. In addition, the structure and composition phase of these methods are studied using the Raman spectroscopy. Consequently, the method of the Raman spectroscopy has found application in the investigation of the historic culture and artifact. It is used to analyze the corrosion of the products on the surface of the statues, poetries. Now, the addition is add to the authentic and historical artifact by comparing the spectra of the surfaces and clean of the code intentionally with that of the spectra of naturally corroded artifact. So Raman spectroscopy is capable of identifying individual pigment and their degradation products. So now you can see the use of the Raman spectroscopy now in the applied science. So that's I would like to say the importance of the Raman spectroscopy when it has been discovered in 1928. They doesn't know the application. Now you can see. So I request to all of our students, all of our new researchers to do the work on fundamental research also. So it is more important. And in the last, I would like to thank our today's guest, of today's speaker, invited to talk, who will going to deliver, Professor Dorendra Singh, Department of Physics, Manipur University. And I wish to success all the program. Thank you very much.
Thank you, Professor Kumar, for inspiring us to conduct research in basic science, and also sharing with us about the importance of Raman spectroscopy in every field of science, especially in material science, how this can be used to know the material characteristics within this technique. Okay, so now I would like to request Dr. N.T. Rikam sir, Registrar Rajiv Gandhi University, to deliver a few lines. Sir, over to you.
Good morning, ladies and gentlemen. I hope I am audible.
Yes, sir.
Okay. Honorable Vice Chancellor, Amitabh Mitra, our guest speaker, respected Professor Dorendrajit Singh from Manipur, Department of Physics, Manipur University. Professor Sanjeev Kumar, Dean, Faculty of Basic Sciences. Professor P.K. Kalita, Head, Jit Singh, the coordinator, Dr. San Bayan, who is chairing the session, all the participants, both faculty members as well as students. At the very outset, I joined the organizer in extending my warm welcome to all of you, especially to our guest speaker who is joining us all the way from Manipur, though online. Sir, you are most welcome to this program. And all the invitees, the participants from both inside the state as well as outside Arunachal Pradesh. Well, this is the day we remember as National Science Day, as we have already heard about the importance of this day. The day is being celebrated to commemorate the discovery of Raman effect way back in 1928 on this particular day when C.V. Raman, the Indian physicist, actually discovered this Raman effect. So I think the Department of Physics or physics communities, they are organizing this on annual basis, and it's annual colloquium and National Science Day. So they are also going to actually conduct online quiz competition. So this is, I believe, befitting to the occasion where the young scientists, young students can participate, and they can join in actually celebrating the day, the National Science Day. Since I don't belong to the department as such, the discipline as such, I cannot make more comment. I would like to hear from our resource persons, from the experts on the importance of today's occasion, the National Science Day, and its evolution, how it come up, and what are the focus areas, what are the plans that we are going to actually do in the days to come. So I must congratulate the Department of Physics for organizing this very important program to commemorate the discovery of Raman effect. We celebrate National Science Day. So I believe this will greatly benefit all of us, the participants students, as well as the faculty members to add on our knowledge about the physics and its utility in our daily life. So with this, thank you very much. Wish you all the best. Thanks all.
Thank you, sir. Now I'd like to request Professor Amitabh Mitra, sir, Pro Vice Chancellor, Rajiv Gandhi University, to join with us and share his thoughts. Professor Mitra. नहीं, हाँ हाँ
Sharon, whether I have to speak now? Because my
Yes, sir.
I did not understand it.
Yes, sir. Sir.
I will speak now, no? Okay.
Yes, sir. Yes, sir.
Because it came, so I was slightly derailed.
Okay.
Now
Okay.
I'm coming.
Okay. Yes. Sure, sir. We are here.
Thank you, Dr. Sharon Ban. Am I audible?
Yes, sir. You are audible.
Okay, thank you. Good morning and namaste to all of you. At the very outset, yes. Good morning and namaste to all of you. Professor Saket Kushwa, Honorable Vice Chancellor Rajiv Gandhi University in absentia, who is in official duty in Delhi. Professor Sanjeev Kumar, Dean Faculty of Basic Sciences. Professor Singh of Manipur University, today's speaker. Professor P.K. Kalita, Head Department of Physics. Other faculty members of the Physics Department. Participants, ladies and gentlemen present. At the very outset, I would like to congratulate the Department of Physics for organizing the National Science Day by starting an innovative program of the annual lecture series for the year. Well, National Science Day is celebrated in every year. On this day in 1928, Professor Raman, he discovered hormone effect after his name, which Professor Sanjeev Kumar has details informed. After 2 years in 1930, he got the Nobel Prize for the remarkable discovery. And this was the first Nobel Prize for India in the field of science. To mark the discovery of this famous phenomenon, National Science Day celebrated India on this day. Objectives of celebration of National Science Day. Number one, to wide daily life of the people. Number two, to display all the activities, efforts, and achievements in the field of science for the welfare of the human beings. Number three, to discuss science and technology. So our duty is to popularize the science and technology for the benefit of the common people. If we come to Arunachal Pradesh, we find that in Arunachal Pradesh, science and technology always got a backseat. Like other developmental activities, that higher education also started quite late in our state, Arunachal Pradesh. In fact, Arunachal Pradesh came in the map of higher education on the first college. Jawaharlal Nehru College was established in 1964. But it took around 10 years to establish the science stream in that college. In fact, for 3 decades, 4 decades, that there were colleges, but only one college with the science departments. At present, that our affiliated colleges are around 45. Only 3 government colleges and 1 private colleges has the science departments. The same case was in the case of the Rajiv Gandhi University. Rajiv Gandhi University was established in 1984. It took around 13 years to establish the first science department, that is the Department of Botany and Department of Zoology in 1997. It took another 15 years to establish the basic science departments, that is the Department of Physics and Department of Chemistry in 2012. So in order to boost up the science and technology in the state, Department of Physics has rightly taken a decision to start the annual lecture series, and this will be a great honor to the renowned scientist, Dr. C.V. Raman. And having a lecture in series allows the students and scholars to get an opportunity to listen to the lecture of famous scholars, enhance the knowledge and interact with the resource person. This, my heartfelt congratulations to the Department of Physics for organizing it. Many departments have tried, but they could not succeed. So I think the other departments will follow the path of the Department of Physics. This will add one more feather in the cap of Department of Physics. My best wishes to the Department of Physics. Thank you very much. Namaste to all of you.
Thank you, Professor Mitra, for showing the prospects, how science can be developed within this state, Arunachal Pradesh. Now, I would like to request our chief guest, Dr. Dharendrajit Singh, to share a few words with us. Professor Singh, so over to you. Sir, please switch on your mic. Sir, you are muted. Sir, please switch on your mic. Sir, you are not audible.
Sir, you are not audible. Please switch on audio.
Okay, is it audible now?
Yes. Please come.
Yes.
Hey.
Good morning to all the members attending in this annual lecture program. First of all, I would like to thank Professor P.K. Kalita for inviting me to participate in this annual lecture program. Also, I would like to thank Professor Amitabh Mitra, Pro BC, Rajiv Gandhi University, Professor Sanjeev Kumar, Dean of Basic Sciences, Rajiv Gandhi University, and Professor Saket Kushwaha, Vice Chancellor, Rajiv Gandhi University, today in absentia, all the members, delegates, and participants. As we know that today is the National Science Day to commemorate the great physicist of India, Sir C.V. Raman. And on this day, we are organizing, the Rajiv Gandhi University is organizing, so as to popularize science to common people. Popularization of science is very essential, is the need of the hour. Unless science and technology is developed, a country cannot be made in progress. So the government of India is also giving us strength to all those workers working in the field of science, giving strength to us so as to strengthen the research in science and technology. And with the remembrance of Sir C.V. Raman and the great Indian scientist who has contributed to the field of science for the development of human mankind. The Rajiv Gandhi University is organizing such annual lecture program, and in my opinion, it is a very good beginning. And in the area of the Arunachal Pradesh, in order to enhance the teaching learning process in the field of science, such popularization of science is very essential, and I thank the organizers for inviting me to take part in this annual lecture program and organizing the National Science Day. So let us unitedly come forward to bring science and technology in a better position in India. With these few words, I would like to conclude. Thank you.
Thank you, Professor Singh, for being with us and sharing your thoughts and your vision. Now, I would like to mention that due to some technical difficulty, our Honorable Vice Chancellor, sir, is not able to join right now, but we hope he will be joining to us very soon. So now I would like to request Dr. Upamanyu Das, Assistant Professor, Department of Physics, Rajiv Gandhi University, to deliver the vote of thanks.
Good morning to all of you. It is my pleasure to deliver the vote of thanks for this events to all the dignitaries assembled here. First, I would like to thank the invited speaker, Professor Dorenajit Singh, Department of Physics, Manipur University, for his giving valuable time for the program. I'd also like to thank Professor Saket Kusaha, Honorable Vice Chancellor, Rajiv Gandhi University, for his support for organizing this program. I'd also like to thank Pro Vice Chancellor, Rajiv Gandhi University, Professor Amitabh Mitra, for his valuable suggestion in these occasions. Finally, I want to thank Dr. N.T. Rikam, Registrar, Rajiv Gandhi University, for his presence and suggestion in these occasions. I'd also like to thank the faculty members of the Physics Department and the participants for making this program as a grand success. Once again, I thank all you present here. Thank you.
Thank you, Dr. Das, for your concluding remarks. Now, I would like to request Professor Pradeep Kalita, Head of the Department of Physics, to take over the next session, basically the session for the invited talk. Professor Kalita, over to you.
Thank you, Dr. Soyan Bayan, for anchoring these universal programs. Now we move to the actual work programs, the lectures program, invited lectures, and this annual lecture series. The first time we have arranged in the department. The basic motive behind this lecture series is to popularize this physics among the students so that they can take this subject as a future career. Also, our objective is to expose a different varieties of area in physics to our young students, so they can understand to this field and make I will heartily welcome Professor Dorenajit Singh to deliver his lectures. So before presentations, his lectures, I request Dr. Sonika to introduce our guest speaker to the audience. Over to Sonika.
Okay. Thank you, sir. Good morning to everyone. So myself is Dr. Sonika, Assistant Professor in Department of Physics at Rajiv Gandhi University. So now let us introduce to our today's speaker, Professor S. Dorenjit Singh. Now he is working on the post of professor in Department of Physics at Manipur University. He did, he did MSc in 1980 from Banaras Hindu University, Varanasi, and PhD in 1995 from Manipur University. His research area is nanoscience and condensed matter physics. At the present, he has 2 research projects and 9 students awarded PhD degree under his guidance, and 5 students are working. Professor Singh is former director IQAC of Manipur University and former Board of Studies member in Department of Physics at Tripura University and Assam University. He is also the Board of Studies member in Northeastern Hill University, Shillong, and Nagaland University. Professor Singh has published more than 75 research articles in reputed international journals and organized several conferences, symposiums, and workshops. So now I would request to Professor Singh to deliver the talk on the topic Role of Science and Technology for Sustainable Future. Okay, sir.
Thank you, Dr. Sonika.
Okay, thank you, sir.
Then I like to invite Professor S. Dorenjit Singh to deliver his lectures. Sir, you can share your PPT. Yes, it is.
Could you see the PPT?
Yes. It is visible.
Yes, yes.
Go ahead.
Uh-huh. First of all, I would like to thank Professor P.K. Kalita for inviting me to deliver a talk on this important day, National Science Day. Today, February 18, the Government of India is organizing today as the National Science Day. So, in the first series of talk organized by Rajiv Gandhi University, the topic which I have chosen is in connection with the theme of National Science Day. So the topic is role of science and technology for sustainable future. The science and technology has to be applied so that in future we could sustain it. So sustainability is very essential. The different governments in the world have assembled in New York to find out what are the different areas to bring sustainability in future. So how science and technology can help in bringing sustainable future. That is what I am intended to talk here. So today I will not concentrate on the research area which I am pursuing in my department in the field of the luminescence in solids and nanoscience. And today, as a popularization of science, I will talk the role of science and technology for sustainable future. Why we organize National Science Day? We organize National Science Day. India organized National Science Day on February 18 every year to commemorate the discovery of Raman effect by Sir Chandrasekhar Venkata Raman in 1928. Honoring a scientist like C.V. Raman instills hope in future generation to pursue their dreams and make a mark in the world of science and technology. Popularization of science and technology is very much essential to give awareness to the citizens of India to bring up India in the global world. Even though Raman effect was discovered in 1928, organizing National Science Day, it arises because of the fact that in 1986, the National Council for Science and Technology Communication, NCSTC, requested that February 28 be designated as National Science Day by the Government of India. So this was a request from National Council for Science and Technology Communication, and it was agreed by the Government of India. So the occasion is now held. That means the National Science Day today is held in schools, colleges, universities, and other science, engineering, medical, and research organizations throughout India to popularize science, to popularize technology, because without science and technology, we cannot progress. So that is the reason why the country, India, is organizing National Science Day on February 28. Although it is on the day on which C.V. Raman discovered Raman effect, it is not only remembering C.V. Raman, but the entire fraternity of the scientists in India who has contributed, who has devoted their life to bring up science for the betterment of human mankind. So, this is the picture of Sir C.V. Raman. You might have come across in many of the places. So, in the website, you will see these things. This is the Sir C.V. Raman, who has discovered Raman effect in the laboratory of Indian Council for Cultivation of Science in Kolkata. So we are remembering such a great scientist who has got the Nobel Prize in Physics just after 2 years of the discovery of Raman effect. He got the Nobel Prize in 1930. And in addition to this, on the National Science Day, we are again remembering another great physicist and biologist, Jagadish Chandra Bose. In 1895, 2 years before Marconi's demonstration, Jagadish Chandra Bose demonstrated wireless communication using radio waves, using them to ring a bell remotely and to explode some gunpowder. So the wireless communication, it was first the work of Jagadish Chandra Bose, even though Nobel Prize were awarded to Marconi. And when the history of science people started searching the different discoveries, so now people have agreed that the real discoverer of wireless communication, wireless telegraphy is Sir Jagadish Chandra Bose. And even the son of Marconi also have expressed, he also agreed that his father got the Nobel Prize, but it should be given to Jagadish Chandra Bose, even though it could not take place. So Jagadish Chandra Bose is a great contributor in the field of physics and biology. Not only physics, he has worked on biology also. He is a great scientist of India. You see, in 1998, IEEE accepted Jagdish Chandra Bose is the inventor of the mercury drop coherer used by Marconi. Jagdish Chandra Bose holds the first patent for the solid-state diode detector based on galena crystal. So, in 1895, Bose gave his first public demonstration of electromagnetic waves, using them to ring a bell remotely more than a mile and to explode some gunpowder. So this was a big contribution by the Indian scientist Jagadish Chandra Bose. We had another Bose, Satyendranath Bose. Satyendranath Bose, as we learn in physics and chemistry about his statistics, Bose-Einstein statistics, he could derive Planck's radiation formula using a completely different mathematical technique, a different concept, introducing a new idea about the indistinguishability of the identical particles, the way it has to be counted, the number of states. Using that, he could derive Planck's radiation formula. In the beginning, his derivation of Planck's radiation formula could not be published. Many of the scientists did not understand his contribution. And Satyendranath Bose sent his paper with a letter to Albert Einstein. After receiving his letter, Albert Einstein immediately translated Bose papers in German language and published in German research paper. And as Bose has given a new concept, Einstein was very much interested, and he further studied for another 1 year. That is how the great scientist, the great physicist Albert Einstein could derive a very important mathematical relation called Bose-Einstein condensation. It was a masterpiece, a very good masterpiece, Bose-Einstein condensation, and it was a very good theoretical work where the particles obeying Bose-Einstein statistics could condensate, could stay together in a single energy state. It was a very big finding by Albert Einstein. It took many years to demonstrate it experimentally. So it was a masterpiece, mathematical masterpiece regarding the Bose-Einstein condensation. And after a gap of 70 to 75 years only, after introducing the Bose-Einstein condensation by Albert Einstein, experimentally, later on, the Bose-Einstein condensation could be observed in a laboratory in two different isotopes, one in sodium and another in another isotope. And those three scientists who could show in the laboratory the occurrence of Bose-Einstein condensation were awarded the Nobel Prize in Physics. Now, in the particles, we classify particles known as the classical particles or quantum particles. And quantum particles, in quantum statistics, we classified in two different types of particles. One is known as the fermion, which obeys the Fermi-Dirac statistics, whereas the other is called boson, with the name of Satyendranath Bose, obeying those quantum particles obeying Bose-Einstein statistics are known as the bosons. So the bosons is a term coined to denote. The term boson has been coined to represent quantum states or the quantum particle obeying Bose-Einstein statistics. So in trying to understand the secret of nature, particle physicists try to explore new type of elementary particles present in nature. So the particle physicists were trying to find out experimentally different type of elementary particles. Theoretical physicists predicted the existence of the different type of quarks. Experimentally also, the presence of quark has been experimentally verified. And one time, there was a time that theoretically Peter Higgs, the scientist from UK, again predicted the existence of a new kind of particle, a new kind of boson particle. Nowadays, it is known as Higgs boson. So that Higgs boson again has been experimentally discovered. So whether it is a Higgs boson, any type of boson, it is in remembrance of Satyendranath Bose. So the birth of the quantum statistics, the birth of statistical mechanics is the contribution of the great physicists like Satyendranath Bose. And the study of the atmospheric physics, astrophysics and others, here again, the Meghnad Saha, the Indian great physicist Meghnad Saha's ionization formula. And from that, a new area in physics has been developed. So Satyendranath Bose has contributed to develop statistical mechanics, quantum statistical mechanics. Meghnad Saha with his Saha ionization formula and others again introduced new areas of physics. So these Indian physicists have contributed a lot in the field of physics. So on the day of the National Science Day, not only remembering C.V. Raman, we are remembering the Indian great scientists like J.C. Bose, Satyendranath Bose, many others. Then again, we are remembering Homi Jahangir Bhabha, who is again a great visionary, a great physicist of India. Because of his contribution, India could have the nuclear power. We could generate electricity using the nuclear fission reaction. It is the contribution of Homi Jahangir Bhabha, the great visionary, a physicist, and with his contribution, India could develop, India could have atomic energy. It could have generate electricity from the nuclear energy. In fact, the Homi Bhabha solved the riddle about cosmic rays. That is, now we are talking about Bhabha's, that the cosmic showering of Bhabha. So Bhabha's discovery of the presence of nuclear particles, which he called mesons, in these showers was used to validate Einstein's theory of relativity, making him world famous. So Homi Bhabha was working in the field of cosmic rays. So during the Second World War, he has to return back in India, and he was working in Indian Institute of Science for some time. And instead of going back in Europe, he thought he will stay back in India. And with the help of young scientists and with the then Prime Minister of India, Jawaharlal Nehru, he could develop Atomic Energy Commission. He was the first chairman of the Atomic Energy Commission in India. Under his guidance, nuclear reactors like Apsara, Cyrus, and Zarlenia were built. So now India can generate energy from nuclear energy. That is the great contribution of Homi Jahangir Bhabha. Not only in the field of the nuclear physics, in the field of the atomic energy. India has contributed again in the field of space science and technology. And with respect to that, we remember Dr. Bikram Sarabhai, the father of space science of India. So Bikram Sarabhai established the Physical Research Laboratory in Ahmedabad in 1948 in a few rooms at the MG Science Institute with Professor K.K. Ramanathan as director. In April 1954, PRL moved into a new building and Dr. Sarabhai made it the cradle of Indian space program. At the young age of 28, he was asked to organize and create the ATIRA, the Ahmedabad Textile Industries Research Association, and was its honorary director during 1949 to 56. He also helped build and direct the Indian Institute of Management in Ahmedabad. Bikram Sarabhai pioneered India's space age by expanding the ISRO, the Indian Space Research Organization. India's first satellite Aryabhata launched in 1975 was one of the many projects planned by Bikram Sarabhai. Like Baba, Sarabhai wanted the practical application of science to reach the common man for the betterment of human mankind. Thus, he saw a golden opportunity to harness space science to the development of the country in the field of communication, meteorology, remote sensing, and education. So we could put many satellites in space because of the great visionary work of Dr. Bikram Sarabhai. So in different aspects of science, physics, space physics, nuclear physics, India has contributed a lot in that. So we need to remember those people in the day of National Science Day. Then we have another great leader, the father of missile technology, Dr. APJ Kalam. He was also the president of India, and he has encouraged the young students to come forward to study science and technology to bring India forward. So he is a man of great vision. And in the field of agriculture, Dr. M.S. Swaminathan's contribution is very great. Dr. M.S. Swaminathan is known as the father of Green Revolution in India. And the agricultural science is developed to a large extent under the guidance of Dr. M.S. Swaminathan. So we remember Dr. M.S. Swaminathan on this day of National Science Day. Then another person is Dr. Varghese Kurir. He has brought white revolution in India. He is the milkman of India. So the production of milk is increased because of his contribution. We remember him as a great innovator. Similarly, in the field of statistics, on this day of National Science Day, we remember Prashant Chandra Mahalanobis. He is known as the father of Indian statistics. He tried to bring up statistics in India, and we have Indian Statistical Institute in Kolkata, in Bangalore, in Delhi, etc. And statistics has become a very good technique to analyze different systems, situation, different phenomena. So statistics has been developed to a great extent under the leadership of P.C. Mahalanobis, and we remember all these great scientists for the development of science in India. So on this National Day of Science, to popularize science, we need to remember all these scientists. There are many others whose names has not yet been bring up here, but we remember all those Indian scientists who has contributed in their respective field for the betterment of human mankind. So to organize the National Science Day, every year new themes comes up. And this year's theme to observe National Science Day, the theme of this year is integrated approach in science and technology for a sustainable future. Similarly, in different years, last year, the theme was future of science, technology, innovation, impacts on education, skill, and work. 2020, the theme was women in science because women should come forward in the study of science. Similarly, like this year's theme, in 2018 also, the theme of the National Science Day was Science and Technology for a Sustainable Future. So this year's theme and 2018 almost nearly same. Only in this year we have added the word integrated approach. How integrated approach is to be applied in science and technology to bring, to keep a sustainable future in art, on this earth. So there are 4 pillars for the integration of integrated approach in science, and it has been announced by Dr. Jitendra Kumar, the Minister of State for Science Technology. So he has given the integrated approach is 4 pillars to integrate of science. So the 2 other pillars, the Dr. Jitendra Singh, Honorable Minister of State, where extended science integration aligned with technical, engineering, and medical institute. And another is extra science integration in alignment with ministry's department of the central government. The 4th pillar, he said, was an extended science-driven approach involving industries and startups leading to a sustainable future. To lead to a sustainable future, startup is very essential. And all of us have seen that the present government has started the startup program to the young research worker, giving money, funds are given, the startup and entrepreneurship program, etc. And that is there in this, the integrated approach of science. So to have a sustainable future, we need to understand about the Sustainable Development Goal. The 2030 Agenda for Sustainable Development, with 17 Sustainable Development Goals at its core, was adopted at the General Assembly of United Nations Sustainable Development Summit held in New York in September 2015. So the United Nations General Assembly has adopted 2030 Agenda for Sustainable Development involving 17 Sustainable Development Goals. And today's National Science Day, the theme is how integrated approach in science and technology could bring to sustainable future. So what are those 17 Sustainable Development Goals? We need to know those Sustainable Development Goals. The first goal Sustainable Development Goal is that there should be no poverty. United Nations is aiming that there should be no poverty in any region in the world. That is the first goal. The second goal is that zero hunger. One should try to achieve food security and improve nutrition and promote sustainable agriculture. How science and technology, we should see how science and technology should be developed so as to apply in agricultural science. So unless agricultural science is developed, then there will be hunger will be there. So United Nations second goal by 2030, no person, no individual one should live with hunger. There should be zero hunger. That is the aim. The third goal is good health and well-being. So every person should have good health and one should live in a better way. And the aim is that by 2030, maternal mortality ratio should bring to the minimum bars. The death should be less than 70. That means whenever a child is born, both the children and the mother should alive. Mother should not be made. So even if the mother is dying, it should be minimum. It should be less than 70 per 1 lakh life bars. That is the aim, to bring good health and well-being. To bring the good health, medical science, science and the technology should come forward to bring good health. Then the fourth goal is quality education. The fifth goal is gender equality. The sixth goal is clean water and sanitation. Universal and equitable access to safe and affordable drinking water for all by 2030. The goal is just to have a sustainable future. Goal number 6 talks about clean water and sanitation to all, not only to the developed countries, but all those people living in underdeveloped country, they should have clean water and sanitation. That is the goal of United Nations. The seventh goal is affordable and clean energy. So ensure universal access to affordable, reliable, and modern energy services. Increase substantially the share of renewable energy. So day by day, the consumption of energy is increasing. So the conventional energy, someday it may lose. There should be alternate sources of energy. Among the alternate sources of energy, the promising one is the renewable energy sources. So science and technology should be developed in such a way that we could tap the energy, renewable energy in a larger extent. The goal number 8 is decent work and economic growth. That is the goal 8. Goal 9 is the industry, innovation and infrastructure. Then goal number 10, reduce inequality. So presently we are seeing inequality among the people staying in different countries. Those in the developed country, those in the developing country, those in the underdeveloped. There is inequality between the different persons. The goal is that we should try to reduce inequality among the people in different countries. Goal number 11 is sustainable cities and communities. So goal number 12 is there. Goal number 13, climate action. Why climate action? Because we know that the climate is changing. The temperature of the atmosphere is increasing. So, to reduce that, the climate action goal is taken by the United Nations. Then, life below water, the creatures inside water, then life on land. Goal 16 is peace and justice, strong institution. Goal number 17 is partnership to achieve the goal. So these are the 17 sustainable development goal which has to be achieved at least by 2030. It was adopted by General Assembly of United Nations. And in order to bring forward, in order that the goals which we are aiming to achieve can be achieved, we require that science and technology in different areas, in different fields, is to be developed so that one can get, say, affordable and clean energy. Everybody should get quality education. Everybody should have good health and well-being. No person should die of hunger. So all these things can be achieved only if science and technology is developed in different fields related to achieve, to attain the different goals of sustainable development goal. So today's theme, integrated approach of science and technology to have the sustainable future. So to have a sustainable future, we have to fulfill the sustainable development goals framed by United Nations organization. And there, the science and technology will be able to do that. So we need to develop science and technology in a prosper perspective. Only the people of science knows about the usefulness of science and technology. We may not achieve those sustainable development goals. So every person in the community should understand whether they study science or not. They should know the importance of science and technology. So popularization of science and technology is the need of the hour. It is very much essential. So to bring the quality education in that sustainable development goal number 4, the targets by 2030 ensure that all girls and boys complete free, equitable, and quality primary and secondary education, leading to relevant and goal for effective learning outcomes. So these are some of the areas. Then renewable energy source. To have affordable and clean energy, we should have proper technology. We should understand the science to tap renewable energy sources. There are 10 top renewable energy sources, and some of them may be restricted to some geographical locations only. In India, we are generating energy using hydroelectricity. Hydroelectricity is the most widely used form of renewable energy in the world, in India also. In addition to hydroelectricity, in the coastal area, we are using the wind energy. And the government of India now and the governments in the different countries are giving emphasis on the use of solar energy. To tap the solar energy, we need to enhance the science and technology. So in the different fields, in the basic science and engineering, the scientists are trying to make a better solar cells. Solar cells already it is there based on say inorganic solar cell, organic solar cell. There are different type of solar cells are there. Using the solar cells from the sunlight, we are transforming to electricity. But still, the efficiency of the solar cell, the present day solar cell, still the efficiency is low. We need to understand the science behind the solar cell, the science behind the production of the materials to be used for the solar cell to tap the solar energy. So there, the science and the technology, still it is there, we are using, but science and the technology, we should study in such a way that we should find out a better form of the solar cell, a better type of material which can tap more energy from the sun, so that, or we should try to make a solar cell having a better efficiency that is required. With the silicon solar cell, as we know, silicon is a semiconductor. It is called indirect band gap semiconductor. The efficiency of the solar cell is less in silicon solar cell because of its band gap. So by varying the band gap of the semiconductor, one day we will be able to with a better efficiency. So in order to use the solar light having maximum intensity to convert sunlight having maximum intensity into the electricity, we need a particular semiconductor with a specific energy band gap that so far we are not able to achieve it. So by band gap engineering, by varying the band gap of the semiconductor, one day we will be able to find out the proper semiconductor so as to make the solar cell which has a much better efficiency so that solar energy can be efficiently converted into electricity. That research is very much needed. Research work on solar material is still going on, but still we have to search for a better material having a suitable band gap which can tap the sunlight having the highest intensity so that the efficiency of the solar cell can be increased. There are different ways, let us see. And a nuclear energy is another. Nuclear energy is clean energy. Unless nuclear accident takes place, nuclear energy is considered to be a clean energy. So we have to tap the renewable energy sources, and this is the need of the hour. We need to increase our research area in the field of the solar energy, nuclear energy, compressed natural gases, etc. And even in the hydroelectricity, also the better way of having hydroelectricity that needs to be found out. So let us come to try to understand something about the Raman effect. He is the Dean of Basic Science. He has spoken about the Raman effect. So Raman effect is related to scattering of light. When light hits, then two effects takes place. One is the absorption of light by the material, another is scattering. The photons change their direction, the scattering of light. Again, in the scattering of light, there are two types of scattering. One is called elastic scattering, another is inelastic scattering. So elastic scattering has been explained well by Lord Rayleigh, and that is known as Rayleigh scattering. And Rayleigh scattering has been utilized to explain why the sky is blue in color. So the elastic scattering of light is of two types. One is elastic scattering, another is inelastic scattering. Again, light can be a normal light or it may be a laser light. As we know the difference, in a laser light is monochromatic if visible. If it is a visible light, laser light is monochromatic, whereas the normal light is polychromatic. Is laser light has good coherence, and whereas normal light is non-coherent. And laser light has directional property, collimated, that is with minimal divergence in parallel, whereas the normal light is non-directional. And a laser light has high intensity, whereas the normal light has low intensity. So this is the difference between the two sources of light, the normal light and laser light sources. So the scattering of light may be thought of as the redirection of light that takes place when an electromagnetic wave encounters an obstacle or non-homogeneity. The scattering material may be solid, liquid, or gas. As the electromagnetic wave interacts with matter, the electron orbits within the constituent molecules are perturbed periodically with the same frequency as the electric field of the incident wave. And in the case of the Raman effect, the scattered light will have a frequency different from that of the incident light. So, in addition to the normal elastic scattering, additional light is scattered at different frequencies, a process referred to as inelastic scattering. So, Raman scattering or Raman effect is a case of scattering of light, is an example of inelastic scattering. So, in the energy scheme, you see in the Rayleigh scattering, the incident light has been absorbed and gone to a virtual state, gone to an excited state. From the excited state, when it comes down to the ground state, it emits light with the same frequency. It is a kind of elastic scattering or known as the Rayleigh scattering. And in the Raman scattering, you see the light has been absorbed, gone here. Whereas in the scattering, light with a lesser energy, that is the Stokes scattering, and light, this is the incident light, and more again another energy is absorbed, and the scattered light has a higher energy, and this is the anti-Stokes scattering. That means the frequency of the scattered light, this red line or this blue line, the frequency of this is different from the frequency of the incident light. And this is known as the Raman effect. So Raman could discover Raman effect in February 28. He announced his effect. He announced the presence of inelastic scattering of light on February 28, 1928. And in this way, Raman spectroscopy started. So before C.V. Raman could get the Nobel Prize, Compton had already got the Nobel Prize that is also related to inelastic scattering of electrons, not in the conventional light, but in other kind of photons. And K.S. Krishnan, the student of C.V. Raman, was very much unhappy when he heard that the Compton had already been awarded the Nobel Prize related to inelastic scattering of X-rays. He was thinking, S.K. Krishnan, he was thinking that Raman may not get the Nobel Prize. When K.S. Krishnan reported to C.V. Raman that Compton we are not working on X-rays, we are working on the light. So don't worry like that. And you see, only after a gap of 2 years, C.V. Raman could get the Nobel Prize in Physics for the discovery of Raman effect. And he did a lot of work in different areas, in acoustics and others. This is a simple instrument used by C.V. Raman to discover the Raman effect. And after the discovery of Raman effect, it has been applied in the fields of physics and chemistry to characterize different molecules. But the thing is that in Raman process, Raman effect, the intensity of the Raman signal, it was very weak. The intensity of the Raman signal, it was very weak. So it was difficult unless one is expert in the field. Detection of Raman spectra, it was difficult. And later on, after the invention of laser, again Raman spectroscopy again comes forward, because as you know, laser intensity is very high. After the discovery of the laser Raman spectroscopy, laser Raman spectroscopy has come again in a big way. So the invention of laser has increased the study of Raman spectroscopy, that is known as the laser Raman spectroscopy. There are new techniques of Raman spectroscopy. One is called surface enhanced Raman spectroscopy, ACRS. Cell isolated nanoparticles enhanced Raman spectroscopy, SINERS, and a tip enhanced Raman spectroscopy. So surface enhanced Raman spectroscopy, these days it has become a very good characterization technique. So surface enhanced Raman spectroscopy is a form of Raman spectroscopy that involves a molecule absorbed in a nanostructure metal surface which can support local surface plasmon resonance excitations. The Raman scattering intensity depends on the product of the polarizability of the molecule and the intensity of the incident beam. The local surface plasmon resonance amplifies the beam intensity when the beam is in resonance with the plasmon energy levels. It leads to the signal enhancement by, say, mega times. The intensity has been increased by 10 to the power 6 times. So it becomes much easier to detect the signal. So Raman, with his student K.S. Krishnan, discovered Raman effect, and he got a Nobel Prize in physics in 1930. And Raman was the first Indian to get a Nobel Prize in science, not only for India, for Asia. Raman was the first person to get the Nobel Prize in science. Later on, many Indian-born scientists, but shifted to US and others, got Nobel Prize in physics and other areas. Physics, then physiology or medicine, chemistry, etc. So this is the basic principle, working principle in surface enhanced Raman spectroscopy. So substrate is there, gold or silver nanoparticle is there, then light is on that, scattering takes place, and the scattered radiation has been collected and got the signals, etc. In the signers, the surface under study is covered with a layer of surface protected plasmonic nanoparticle, and then the Raman spectrum is recorded. The plasmonic cores of gold or silver or gold of the core cell structures used in signers experiments are covered with a very thin, typically 2 to 6 nanometer layers of chemically inert oxide such as silica, silicon dioxide, or alumina or manganese dioxide. The cell oxide layer prevents direct contact between the surface and the metallic plasmonic core, such that those plasmon resonance can be easily detected. This is important to analyze biological samples, since some biological molecules such as DNA or proteins in a native structure could be denaturated when interacting with metal surfaces. So about the Raman spectroscopy, there are many applications related to the characterization of material. So Raman spectroscopy has been applied to pharmaceutical and cosmetic. It has been applied for in geology and mineralogy, in the carbon nanotube materials, in semiconductors, in the study of semiconductors, in the study of life sciences, to characterize the biomolecules and the drug cell interaction, etc. Raman spectroscopy is very much essential. So spectroscopy is used to understand, say, in terms of mineralogy, how can we know that a diamond is a natural diamond or a synthetic diamond? A natural diamond will have a particular wave number. The signal is in a particular wave number around 13,1300 centimeter inverse. If it is a synthetic one, you will not get a signal in that way. So from the spectroscopic technique, the natural diamond and a synthetic diamond can be easily separated out. So that is about the Raman effect. Now let us come to another interesting area about the lighting technology. So the lighting technology, as we see, first we used to use, say, kerosene and others, then the candle, then the bulb, incandescent bulb, then fluorescent, compressed fluorescent light, then lastly LED comes around 2008. So the present day, 21st century, the lighting technology is based on LED. It does not consume much energy, but its intensity is very high. So the lighting technology of the 21st century is based on the LEDs, light emitting diodes. So to have affordable and clean energy for lighting, LED is very much essential. And in the LED, while we use the LED, we want for general use white light emitting LEDs. For certain cases, we need the colored LEDs, say the green light, blue light, red light, yellow light, those things for specific application. But in general, inside a house, we need white light. So we need to produce the white light LEDs. So for the production of white light LEDs, again, Nobel Prize were awarded to three Japanese Japanese-born 3 scientists, one become American citizen. So they were awarded the Nobel Prize. You see, Dr. Isamu Akasaki, then Amano, and Nakamura. Nakamura later on become American citizen. So University of California, Santa Barbara. So these 3 were awarded the Nobel Prize in Physics in 2014 for the invention of efficient blue light emitting diodes based on gallium nitride semiconductor. So earlier red emitting LEDs, yellow emitting LEDs, blue, then green emitting LEDs had already comes up. But because of the lack of the blue LEDs, production of white light was not possible. But these 3 Japanese-born scientists, 2 Japanese scientists and 1 Japanese scientist, American scientist Nakamura, the 3 were awarded Nobel Prize in Physics 2014 for their invention of efficient blue light emitting diode, blue LEDs, based on gallium nitride. So LED technology, lighting technology of the 21st century, it has contributed by many scientists, but the award was given to these scientists for making the efficient blue light emitting diodes. You see the light of different lumens. The candle light, 0.1 lumen per watt, and incandescent light bulb will give 16 lumen per watt, whereas the fluorescent lamp, fluorescent tube will give 70 lumen per watt, whereas the LED light can give light with a brightness of 300 lumen per single watt. You see, this is a great change. So with the use of the LED, with very less power, it can have brightness, much brightness. So this is the lighting technology of this 21st century. Still, the research on LED, still it is going on. Although the Nobel Prize in LED, blue LED, has been given, Nobel Prize in Physics for the discovery of blue LED has been given to the 3 scientists. Still, the area is quite interesting. People are again searching better material to make the LEDs. So this is an area where the physicists, chemists, and engineers come together to find out a better material to make the LEDs, which can give a better luminosity, which can give a better material, long-lasting, and others. The present day LED is also long-lasting, but even we can search different materials having a longer longevity and giving a better luminosity, and still the research on searching the material for making the white light LEDs is going on. That is an interesting area. The students of physics and engineering can come forward to make new materials which can be used for making LEDs. Some of the physicists and engineers can make semiconductors, a better semiconductor to make solar cell of having a better efficiency. So solar energy will be used one way for solar cell, making solar cell to tap the solar energy to convert sunlight into electrical energy. Another to make the LED. So in the semiconductor industry, in the semiconductor research, scientists from physics, chemistry, and engineers should come forward to make a better material better semiconducting material to make LEDs, to make the solar cell, so as to tap the solar energy in a better way. So this is one area. Again, let us see in another area. In the field of cancer research, cancer is a deadly disease. So it is one of the diseases. Cancer is one of the diseases which kills human beings. And as the scientists are, doctors are trying to find out, the scientists, biologists, then are trying to find out the medicines to cure the cancer. So in the field of the cancer research, one group of scientists will devote in the process of detection of cancer. Another group of scientists and doctors will involve in making the drugs to cure the cancer. So in general, the present technology in detecting the cancer, different form of cancer is detected mainly in the later stage when the person is about to die within a few months. Only then the cancer is detected. So early detection of cancer in the early stage still is a big challenge to the scientists. So the scientists are trying to find out the proper biomarker that can be used for the early detection of cancer. Even in Manipur University, in the Department of Biotechnology, they are searching the biomarkers for the early detection of cancer. So I am just representing one of their paper, bioassay guided isolation of certain materials from Oroxylum indicum. It is, the flower is shown on the side. And from this, they have isolated a particular molecule having a molecular mass of 330. And our researchers in Manipur University is claiming that this particular molecule is a novel anti-cancer compound isolated from Shamba. Shamba is the local name, and scientific name is Oroxylum indicum. And from this, they have found out anti-cancer compound. This can be considered as a biomarker. So people around the world are searching different types of biomarkers for the early detection of cancer. So in the cancer research, biomarker is very essential. And so according to the National Cancer Institute, a biomarker is a biological molecule found in blood or other body fluids or tissues that is a sign of a normal or abnormal process. As you know, cancer is abnormal growth. So whether by testing the blood or tissues of the body, whether the person has a normal process or abnormal process, that way it will try to detect it. So, or of a condition of a disease. That is NCI defining the biomarker. Cancer biomarkers are biological molecules produced by the body or tumor in a person with cancer. Biomarker testing helps characterize alterations in the tumor. Biomarkers can be DNA, RNA, protein, or metabolomic profiles that are specific to the tumor. Finding biomarkers for detecting cancer at early stage is the main focus of cancer research. MicroRNA, ribonucleic acid, is the biomarker which many are studying. So, in the field of the cancer research, many of the scientists are trying to find out different type of biomarkers for the early detection of cancer. Then, in the therapy, in the field of the nanoscience, combination of doctors, then biologists, then many others. They are trying to find out suitable nanoparticles to have a nano drug delivery. As we know, doxorubin is one drug used to kill the cancer cell. How can a nano-sized doxorubin placed can be placed in the exact place where the cancer cell is there? So in the field of nanoscience, in medical science, there is term called nano drug delivery. In this nano drug delivery system, the drug, almost in a nano size, will be carried through the blood vessel, and it will be placed, it will bring to the proper place where the cancer growth is there, so that the drug will interact with the cancer, so that the cancer cells can be killed by using the drug. Say the doxorubin is, for example, one drug to kill the cancer cell. And that can be carried by covering with other nanoparticles. So in this field, in the nano drug delivery, many scientists are also engaged in that. Let us come another area that is called gene editing. These two scientists, Charpentier and the Reichert Doudna, they too were awarded Nobel Prize in Chemistry in 2020. And the same two persons with another one, again, were awarded in 2018 Kavli Prize in Nanoscience for their discovery for the development of a method for gene editing. So, in the gene editing, what they are trying, they are cutting one part of the gene, one part of the DNA they are cutting, and they again join the genes, etc., with a molecular means, how to cut the genes, how to make a scissor to cut the genes. So gene editing is very essential. They are thinking that by means of the genome editing in the process of therapy and others, it will be quite useful. It is a new area in the field of biological science. In the genetic science, gene editing, say for the invention of CRISPR-Cas9, a precise nano tool for editing DNA, causing a revolution in biology, agriculture, and medicine. So these two lady scientists, Charpentier from Max Planck Unit for Science of Pathogens, Berlin, Germany, and Jennifer A. Doudna from University of California, Berkeley, USA, they developed a method of genome editing, and they are making genetic scissors, a tool for rewriting the code of life. The gene is to be rewritten again. So the scientists are expecting by modifying the gene, even the cancers and others can be cured. The abnormal growth, such as the cancer, someday it might be checked by editing the gene. This is another area which is coming up widely in the field of the biology. In the field of biology and medical science, gene editing is a very important area in that. So these two scientists were given Kavli Prize in 2018 and Nobel Prize in Chemistry in 2020. Then again, if the UN is having a goal to have no hunger, then food should be produced in plenty. How science and technology will help in agriculture for sustainable future. Technological innovation have greatly shaped agriculture throughout time and has become a larger component of quality control in agriculture. Science and technology is applied in agricultural activities to improve the crop yield, pest protection, disease management, storage of the crops for the long life, high yielding, and also predicting the weather. Then how the farmer can improve the productivity of his crops. In that case, he has to follow the instruction from the scientists, agricultural scientists and others. So the improved farmer efficiency is very much essential. So mechanization is very essential. Let us see a major advance in agriculture is the use of artificial intelligence. As you know, artificial intelligence is an area in computer science and engineering that has been applied now in agriculture. Modern equipment and tools based on artificial intelligence enable data gathering and assist in precision farming and inform decision making. Drones, remote sensors, and satellites gather 24/7 data on weather pattern in and around the fields, providing farmers with vital information on temperature, rainfall, soil, humidity, etc. And such a knowledge will greatly enhance in the production of the uh, food products and others. So here the importance of science and technology in the field of agriculture is coming up. Agriculture refers to a wide resource of methodologies that include traditional breeding method, genetic engineering, and the development of microorganisms for agriculture. Genetic engineering uses the understanding of DNA to identify and work with genes to increase crop resistance to pests and the development of high yielding variety. So, in order to fulfill the aim of no hunger agriculture, the area of agriculture is to be enhanced. The study on agriculture is to be enhanced by studying the science and the technology related to the agriculture. So some of the emerging agriculture technologies for sustainable future is related to soil and water sensor, weather tracking, satellite imaging, pervasive automation, mini chromosomal technology, radio frequency identification, particle farming. So with respect to agriculture, the science of agriculture, certainly the production of food can be enhanced so that the goal of having no hungry by 2030 is resolved by General Assembly of United Nations can be fulfilled only when we improve the method of agricultural technology. Let us come to another area of the physics, chemistry, or biology in the field of microscopy. Microscopy is very essential. An experimentalist in physics working on material science need to understand fully about microscopy. The basic principle of microscopy is that seeing is believing. If we see it, we believe it. So, in the history of science, the concept of atoms were introduced. When the concept of atom were introduced, many of the scientists were saying, no, it is just an imaginary, the word atom. Now, by discovering electron microscope, atom is visible now. Once we see the atoms of different elements, we believe it. So, seeing is believing is the motto of a microscopy. So, microscope, as you know, is a tool that magnifies and improves resolution of the component of a structure. So, in the beginning, microscopy, as you know, it starts with optical microscopy. And optical microscopy had limitation to see the smaller objects. That is how a better advanced form of microscopy called electron microscope was discovered by Ruska and a Roller in 1931. So, this is the transmission electron microscope, a kind of microscope better version of transmission electron microscope. The first transmission electron microscope was discovered by Ruska and Rohrer. So just after the discovery of the electron microscope, not studying the materials found in nature, the inanimate materials, but also the biological materials, where the structure of biological materials were studied by using the electron microscopy. The discovery of electron microscopy not only changed the idea of physics and chemistry, but it has totally changed the science of biology. Before having the electron microscope, the constituent of cells, plant cell and animal cell, the constituents were minimal because they could not see the smaller one. But after the discovery of the electron microscope, they could see more and more the smaller ones present inside the living cells, like the plant cell and animal cell. That is how the study of biology is completely changed with the discovery of electron microscope. Electron microscope, as you know, a physicist like Ruska and Rohrer made it. It was used to see the structure of different materials, including the biological material. And after that, in 1980s, 1980-81, the middleman, Gerd Binet, he discovered another version of microscope whose utility is comparable to that of the transmission electron microscope. And that electron microscope is called scanning tunneling microscope. And this is Ruska, discoverer of TEM, transmission electron microscope, and Gerd Binet, and this is Rohrer. These two scientists discovered scanning tunneling microscope. And in the case of the transmission electron microscope, one can see the two-dimensional images in the nano size, whereas the scanning tunneling microscope could see the three-dimensional structure. That means it can see deep on the surface of the material itself. And for the discovery of the scanning tunneling microscope by Gerd Binet and Rohrer, and the first electron microscope discovered in 1931 by Ruska and another scientist, Ruska and Knoll. Knoll is no more when Nobel Prize were awarded. So these three scientists were awarded the Nobel Prize for the discovery of electron microscope and scanning tunneling microscope. And what is the physics behind the scanning tunneling microscope? Is we study in the quantum mechanics about the tunneling current, quantum tunneling. So in the scanning tunneling microscope, using the Josephson junction effect in superconductors like that, in the scanning tunneling microscope, there is a very small tip. There will be hardly 100 atoms on the tip of the scanning tunneling microscope that will touch on the top surface of the material whose surface structure is to be seen. So the quantum tunneling current between the atom on the top of the specimen and on the atom at the tip of the STM, a small tunneling current in the very small current, nano to nano ampere ranges, those tunneling currents, 10 to the power minus 9 amperes to 10 to the power minus 12 amperes. That range of current has been measured by scanning the tip on the surface of the structure. And the variation in the depth, the variation of current is expressed in terms of the structure of the surface morphology of the material. That is how, with the scanning tunneling microscope, one could see the three-dimensional structure of a nanostructure itself, for which the three persons were awarded Nobel Prize in Physics. But the lacuna of the scanning tunneling microscope is that it could see only the conducting surfaces. Non-conducting surfaces cannot be seen by using the scanning tunneling microscope. That is the reason why Gerd Bennig thought to discover another new kind of microscope which can see not only the conducting surface but also the non-conducting surface. That is how in 1986, on which he will be awarded the Nobel Prize for the discovery of the scanning tunneling microscope, he has discovered another kind of microscope called atomic force microscope, AFM. So in the scanning tunneling microscope, tunneling current was measured and microscopy was done. Whereas in the atomic force microscope, the weak force of attraction or repulsion, weak force of attraction like van der Waals force of attraction between the atoms on the top of the material whose structure is to be discovered, along with the top, the atom at the bottom of the tip of the AFM, the force in the range of nanonewton has been measured. The force between the atoms when they are separated by a distance of 4 to 5 nanometers, it is in the range of nanonewton force, and that force has been measured. And by measuring that force, he could again develop a new kind of microscopy that is called atomic force microscope. With its help, it could see both the conducting and the non-conducting surface. So in 1986, Gerd Bennig discovered atomic force microscope. The physicists discovered STM, electron microscope, and the atomic force microscope. Presently, atomic force microscope become a very good equipment for the biologists, for the medical scientists to study the structure of the biological molecule like the proteins, different proteins and others, to see the biological molecules, nano-sized biological structure. AFM becomes a very powerful instrument to study the biological molecules. So the microscopy is very essential, and it has been utilized. And these three scientists were awarded the Nobel Prize in Physics for the discovery of the microscopy. And the idea was that optical microscope, because of Abbe's diffraction limit, it cannot see the objects smaller than 0.2 micron. That was Abbe's diffraction limit. So optical microscope were unable to see the nano-sized structure. And that impossibility, just like the common people, just like in the books, it is written that Napoleon, in the dictionary of Napoleon, impossible word is removed. There is no impossibility in the mind of the Napoleon. Like that, the impossibility of seeing the nano-sized structure by the optical microscope is given by the theory by Abbe using the principle of diffraction of light. That was again broken. That impossibility has been broken, and that means optical microscope were used to see the nano-sized structure, and for which three scientists, these Erik Bedzik, Stephen Hall, and Morner, they three again were given the Nobel Prize in Chemistry in 2014 for the development of super resolved fluorescence microscopy. They three were. They use optical microscope, not the STM, not the AFM, not the transmission electron microscope. And they break Abbe diffraction limit, impossibility of seeing the nano-size structure by using the optical microscope that has been broken by these three scientists. That means optical microscope in the present day has become a nanoscope. Earlier, optical microscope was unable to see the nano-size structure. Now, the optical microscope is also able to see the nano-size structure, so that optical microscopy become nanoscopy. And these three scientists were given the Nobel Prize in chemistry. Why in chemistry? All the three are physicists, and they work on biological molecules. They work on biological molecules, but they got Nobel Prize in chemistry. Why? Because they are looking the structure of biological molecules in the size of atoms and molecules. As you see, atoms and molecules are studied in chemistry. But physicists are physicists. They work on microscopy using the biological molecules. And those biological molecules, the sizes which they measure in the size of the atoms and molecules, that is how they are given Nobel Prize in chemistry. Say one example, lysosome structure, lysosome imaging by single molecule microscopy, single molecule fluorescence microscopy. This is by Eric Berger. They could see a better picture. On the right side, you see, instead of this image, here, a better image you could see. So, Eric Berger detected fluorescence in single molecules using near-field optical microscopy. So, they break down AB's limit and could see nano-size structure. Here, comparison of the transmission electron microscope, the different components of the transmission electron microscope. Here, diagrammatically, here it is shown the different components. Electron gun is there, acceleration stack is there, condenser lens are there, sample holder is there, objective lens is there, then projector lens. Lastly, the image is seen on the fluorescent screen. So in the electron microscope, instead of the light rays, the electron beams are used to see the image. And this electron beam has been accelerated by applying the high voltage. It is having energetic. So if we try to see a living biological molecule, a living biological material, then the energetic electron beam sometimes used to kill the living cell. So, with the hope to see the structure and the dynamics of the living cell, sometimes the energetic electron beams used to kill the living cell. So, instead of seeing the living cell by using the transmission electron microscope, one has compelled to see the two-dimensional structure of that cells, etc. That was one of the disadvantages of the transmission electron microscope in the biological science. So that is why they have chosen the atomic force microscope to study the biological molecules. But again, if the innovative idea is there, even the biological molecule can safely be seen by using the transmission electron microscope by modification. By modification, that can be seen. So AB is the diffraction limit, D equal to lambda by twice n sine alpha. So lambda is the wavelength of light used, and alpha or theta is the semi-vertical angle, and this is the refractive index of the material. And what is the size, the limit of resolution is restricted by this. For the optical light, you see the visible light, the wavelength ranges from 3000 to 7000 angstrom. So if you replace here the value of lambda, the limit of resolution D is it cannot come down to the nanometer side. That is what is called Abbe's diffraction limit, and which tells that optical microscope cannot see an object still smaller than 0.2 micron by using this formula. But that has been, that restriction, that limit has been broken by these three scientists using optical microscopy, but by using the different principles. Then again, using the transmission electron microscope, again, these three scientists were again given Nobel Prize in Chemistry in 2017. The left-hand side is Jacques Dubocet. And Dubocet found now a method of making disordered ice. Instead of water, when it cools down at 0 degrees centigrade, it becomes ice, solid ice. And if the cooling process is very slow, then from liquid water, it changes into a crystalline ice. So to see the structure of the living cells in the crystalline ice, or a glassy structure ice. As you know, in the formation of a glass, while making a glass, sudden cooling is done. And as you know, glass is not crystalline, it is a disordered structure. So using that technique, Jacques Dubocet made freezing by sudden cooling, and he could make the amorphous ice, not the crystalline ice. So the living cell, whose dynamics is to be studied by looking through the transmission electron microscope, it has to be cooled down below 0 degrees centigrade, not by forming crystalline ice, but by forming the amorphous ice. That was done first by Jacques Dubocet. And his idea has been used by Richard Henderson also. Richard Henderson is working in the Department of Molecular Biology. And Joseph Frank is in Columbia University, New York. Jacques Dubocet, University of Louisiana. So these three scientists, for developing cryo-electron microscopy for the high resolution structure determination of biomolecules in solution. So by developing a process by which crystallization, by which the ice formation, solid formation, amorphous ice has been made, a method first introduced by Dubocet that has been utilized for the high resolution structure determination. And that is how they could capture the dynamics of living molecules in the atomic detail. In terms of the nanostructure, atomic detail, the dynamics, the movement of the biological molecules, proteins, etc., they could see by using not the optical microscope, not the atomic microscope, but by using a new kind of transmission electron microscope called cryo-electron microscopy. For their groundbreaking discoveries leading to develop cryo-electron microscopy, the three were awarded Nobel Prize in Chemistry. Here you see also they have given not in the physiology or medicine, not in physics, but in chemistry. And this Josiah Frank is a very good computer specialist using the different algorithm and others. He could bring the two-dimensional TEM images, multiples of two-dimensional images has been made, and he could make it, convert it into a three-dimensional structure of the biological molecules. You see the three-dimensional structure of the biological protein molecule using the cryo-electron microscopy, the protein structure. So Henderson and Unwill replaced water with a glucose solution to preserve samples in a vacuum and use the new preparation method in studies of, in fact, protein crystals. Radiation damage in the electron microscope was analyzed systematically, and electron intensity was adjusted at a lower level to minimize the effects of electron radiation. And they could find out, using cryo-electron microscopy, they could find out the structure of the molecule. This is the work of Henderson. You see, using those cryo-electron microscopy, figure 1a, a protein complex that governs the circadian rhythm. So day and night variation, which we usually know, because that circadian rhythm through our brain is because of the protein complex and the structure of that protein complex that governs the circadian rhythm. The structure is this. Then this is a sensor of the type that reads pressure changes in the ear and allow us to hear. That is, the structure is given. And a Zika virus. You see, these structures in a nano size can be seen. The three-dimensional structure of these complicated biomolecules can be found out by using the cryo-electron microscopy. If you see Nobel.org in the Nobel Prize declaration, you will be able to see these pictures. And this is the Gary Ports, the structural biologist, was looking at a database of human proteins. Individual proteins like this protein found in blue-green algae help regulate circadian rhythms. So, with the help of microscopy, studying the structure in a nanometer size, it has increased in the understanding of the dynamics of the biological molecules. So the dynamics of biological molecules can be studied by using powerful microscopes. So Dubosset's method of making glass from water means water, when it cools, not forming a crystalline water, but amorphous water. That is a glassy structure. The ice is having a glassy structure, amorphous structure. That was the first contributed by Jacques Dubosset. You see, using the cryo-electron microscope, this is cryo-electron microscope. Micrograph of adenovirus preserved in amorphous ice. The structure clearly it is seen by using the cryo-electron microscope. So Dubosset generated the first images of viruses surrounded by vitrified water. In 1984, it was published in Nature. So this is the work of Dubosset, who has made the amorphous ice to study the biological molecule. He had studied adenovirus. Again, you see, another scientist, Henderson, by using the cryo-electron microscope from the two-dimensional electron structure, it has been made into a three-dimensional structure. This is the first rough model of bacteriophodopsin. The resolution of the image was around 7 angstrom. With a 7 angstrom resolution, by taking large number of two-dimensional images, lastly, a three-dimensional structure of the protein molecule of this has been made by Henderson. Henderson achieved his goal and was able to present a structure of bacteriohodopsin at atomic resolution. Again, this is another. They carry on studying on different biological molecules. You see, earlier, the resolution here, it is superposition. Here, resolution was less. Resolution before 2013. And after that, at present, the resolution, it has come to this stage. So because of the improvement in the resolution of the microscopy, the study of the biological molecules has completely changed that idea they used to coin a word, globology, to revolution. Earlier, it was like just a blob, congregation of large number of structure, but now it has been in a minute way. In the present day electron microscopy, using the cryo-electron microscopy, the structure becomes more clearer. That is how the microscopy has changed. Similarly, ribosome structure is shown here. Then we should try to, one of the goal of the sustainable development goal is to achieve affordable and clean energy. So to tap the clean energy, India also needs to develop science and technology in a better perspective. Not only using the petrol, coal, etc. In addition, not only using that, atomic energy which we are using, the total amount of energy which we are consuming worldwide in the atomic energy is not large. Similarly, hydroelectricity also is there. Then we need alternative source of energy such as the solar energy. Here it is showing in US itself in 2020 petroleum consumption 35%. Out of the total energy consumed, petroleum will share 35%, coal 10%, nuclear power 9%, natural gas 34%, whereas renewable energy 12%. Out of this renewable energy 12%, different sections are there. Wood is there, biofuel, biomass, waste, wind energy, hydroelectricity, solar energy, geothermal energy. In India, we are using hydroelectricity. We started using the solar energy, and in the area of the solar energy, hydroelectricity, mostly it will be done by the engineers, but tapping the solar energy, the physicists has to play a big role in that. So research in the area of the solar energy to tap the solar energy, either making materials for white light emitting materials, white light LEDs, and making the proper solar cell to have a better efficient solar cell to tap the solar energy is the need of the hour. Here, we need those things. And to make the different materials, many research is going on, both chemistry, physics, and different disciplines of engineering now is working in different aspects of nanoscience. And in the field of the nanoscience, future in the production of the energy is a supplementary. We have to use the solar energy, and we have to find out a proper material to have the white light emitting sources. And in my department also, we are working on the nanomaterials producing the white light that I'm not showing here, but here's showing some of the pictures. This is not mind work, just giving an example how the nanostructure materials are used. So many more are there. Science and technology is a vast area. In 1 hour, it will be very difficult. It will be an impossible task to cover major areas in science and technology. I have compiled a few areas in the field of physics, in the field of nanostructure, in the field of microscopy, etc. And lastly, I to the research scholars and to the students, there is a wide scope in the study of science and technology. You please come forward, try to do research work. When you continuously carry on research work, someday, unexpectedly, innovative idea will also come up. And with that innovative idea, if you proceed in the research process, sky is the limit. You can make good progress in that. Come forward. And not only doing research in the field of science and technology, not only confining to ourselves, let us try to spread the knowledge to the common people. Let everybody, every common man, understand the utility of science and technology. Let us also feel that science and technology should be pursued by the younger generation. With these few words, I would like to thank the organizer for inviting me. And lastly, I give acknowledgement to Dr. T. Gomti, Department of Physics, Manipur University, Professor Sanju Kumar, Department of Biotechnology, Manipur University, E. Sitra, Research Scholars in Physics Department, O. Priyoda, Biotechnology Research Scholar, Biotechnology Department, for sharing their thoughts in making this talk fruitful. With these few words, I'd like to conclude here. Thank you all.
Thank you, Professor Singh. It was a very nice talk. We have enjoyed, not only enjoyed, but his talk, the role of science and technology for the science sustainable research in the line of the present today's theme of Science Day celebrations. It's very good, and Professor Singh, he has identified the 17 up to the 2030, and Professor Singh also, he has explained the gradual development of science and technology globally, that how it is developed, the present stage, and what is the scope at the present state, and how our young student, they can take this particular field for the future research. Dr. Singh, he has explained some of the very interesting some things in that is the area, the renewable energy, that is how this can be make an integrated approach in futures for development of the better solar cells and some of the nanomaterials that can be also developed, uh, particularly in the development of material science. He has explained the invention of blue LED. That is a very remarkable, wonderful discovery, and how it leads to a change in the luminescence field. And another is the fundamental concept of the Raman scatterings, its applications, and its relevance as a powerful characterization techniques in material science at the present hours. And our student will learn the different other technique also. He has also explained some of these microscopies, because the electron microscopy is also one of the powerful techniques in the material science. So how this technique develop, the sir has explained nicely, and what is its present state and why it is needed in the material science. We can get the information. Also, sir has explained some of the recent development in the biomedical research, starting from the study on different type of anti-cancer molecule. Basically, he has shows the extraction of this molecule from the locally available plant by using the nanomaterials and the genetic engineerings. And this genetic sensors, this is a very remarkable one of the milestone discovery, as I think, because it will rewrite the life in futures. So there is a wide scope. So one can collaborate with the life science department to come into field. And I hope this overall this lectures, it was a very good. I heartily thank Professor Singh for giving us his valuable time and share his views in the line of the present day theme of National Day celebration. Thank you, sirs. Then I would like to discuss the topics as sir presented. If any query from the audience, we can discuss it.
Thank you, sir. Thank you for a nice lecture. I have a question regarding the electron microscopy. So most of the researchers, including me also, we have experienced one difficulty while capturing the microscopy images of two-dimensional graphene or carbon-based rods. So in most of the cases, what we have found that there is a burning of the layers, 2D materials under electron microscopy. So is there any remedy, or what can be the solution of such kind of incident that we don't want to destroy our samples? So is there any solution to get the image properly?
What you are telling that while trying to see the image of the graphene structures, when the electron beam bombards a material, the material has been burnt.
Yes,
is it the
sir,
way?
yes, exactly.
Then I think, even if I have not done, I think that just like seeing the biological molecules, so biological molecules, it has to be seen. Like in a cryo-electron microscopy, it has to cover with the amorphous ice, etc., to see the structure of that, so that it will not burn the material.
In that process, can we still observe the lattice fringe pattern? Can it be visible in that process also?
Lattice pattern, because the amorphous structure, those things will not be seen. Only for lowering the temperatures and others, I think the structure will be able to see, in my opinion.
Only the morphology can be found, other than the high resolution images.
Morphology, it must be able to see it.
Okay, so in that case,
because that the amorphous eyes, it will be almost transparent, but the structural material, it will be able to see that.
Okay, sir, I have another question regarding the white light LEDs or whatever the LEDs you have been discussing. I had that query in my mind that today we have already achieved a state where the price of a small LED comes in a rupees around 1 or 2 max. Any further research or development is required to get any alternative material? The materials which are already there, we can have LEDs in 1 or 2 rupees. So, is there still any scope for the research in this field?
I think still the research in this field will be there because we have to search the material where the rare earth materials is not used. But the present day technology, at least they are using the rare earth material. So the price can be still come lower down if we use a material where it gives the white light, but no rare earth is used. Then the cost and others, it will be reduced. Still, because the materials which we are using is, it will someday it will have, it will exhaust. We have to search another material also. For producing the same amount of white light, we need different kind of material having similar kind of the property giving out the light or better one. That is still it requires.
Okay, sir. Okay, thank you.
So any other question? Any other question? So if there is no question, then I have a one general questions.
Yes.
Yes, Professor Singh. We have a very brilliant scientist before the independence. Our science is it was very wonderful. Good discovery was. We have a good numbers of scientists, original research. But after independence, or we are not able to get the such award as a Nobel Prize, I think if there is some lack of originality or we are deviating from the original research or something, there is a good lack of policy from the government.
Yes, Professor
Yes,
Kalita.
Yeah.
Yes, what you said, it is correct that before independence, India had a very good researcher and a well-known, worldwide well-known researcher. And the progress in science in the other countries, the way it has progressed, it has gone to a heights. The rate is very high. On the other hand, in our country, it becomes less. So I cannot say, just an opinion is that we need to concentrate more. If we Indians, if we go out, other countries, say USA and others, because of the necessity work hard, much more work hard. So we have Indian born but American citizen
Yeah.
Nobel laureates,
Yeah.
but not India itself. And those people are not. That is one aspect. The hard working, the degree of hard working, still, I think we are lacking to a certain extent. That is one. On the other side, the policy of the government. It is not good that we blame the government and others, but if we see, if we just analyze how much percentage of GDP in other developed countries is given for education, whether it is given in India.
Yes.
That is lacking. That is lacking in reality. We are not telling to the government this way, that way. But if we see from the data, statistics published by the government itself, then the money, as per the GDP, how much percent of the GDP is given the funding, that is less. That needs to be improved. Only telling in the television that we'll try to improve science and technology, innovation should be there. Always imposing innovation. Innovation always may not come. Depending on hard work and others, sometimes it may come, but at least the policy will be such that even for in one way they are giving money based on the ranking in the different universities. So better universities are pouring more and more money, and smaller universities are getting very small pie of the fund. So percentage of the GDP, more percent of the GDP is to be given to the education sector, research and others. For publication, they should encourage that. That needs the government needs to fund more money for that.
Thank you, sir. The government is already taken the different steps, several steps in recent years. I have seen, especially for the development and science and technology, different schemes are launched in different times.
The schemes are there, but how much percent of the GDP? That is still less.
Still less.
That is still less. It needs to be increased.
Yeah. That is one of the factors. Yes. And this year theme is the integrated approach of science and technology for sustainable development of science and technology. So in university level, how this integrated approach can be materialized, whether it is a collaboration with the different department or something else we can do.
As per the new education policy, in my opinion, so collaboration between the faculties in the different department. Before this new education policy, also it is required. Now also it is required. Instead of confining in the department itself, interdepartmental collaboration inside the university, between the universities is needed. And for that, certain amount of funds and others is needed.
Yeah. Thank you, sir. Once again, a great thank you to Professor Lorendrajit Singh for giving us his valuable time for taking part in discussions also. Then I like to invite Dr. Jyoti Jaiswal for a brief appreciation with a summary of the talk. Dr. Jaiswal.
Ji, sir.
Yeah.
Thank you, sir. And good afternoon to all of you. Myself, Dr. Jyoti Jaiswal, Assistant Professor, Department of Physics. Wish you all a happy National Science Day. It is a great pleasure to be here for this special event, Annual Physics Colloquium, come National Science Day. It is my humble honor and distinct privilege to hear you all attendance here today on this special event organized by Department of Physics, Rajiv Gandhi University, Arunachal Pradesh. So first of all, I would like to special thank you to our chief guest, Professor Doranjit Singh, for delivering such an amazing, informative, and very interesting talk on the role of science and technology for sustainable future, and sharing the knowledge on various issues such as why National Science Day is important to celebrate for in our country, and also the sustainable development goals, what is the sustainable and renewable, the prospects of nanoscience and nanotechnology on the present disciplinary, that is the role of physics, chemistry, and mathematics and biology. Need basically today is the interdisciplinary. We need to collaborate in different field, because today research is completely interdisciplinary. Not only chemistry, it is not only biological field, so and not is only agriculture sciences. So in every field there is a role of physics, chemistry, and mathematicians also, and biological persons. So we hope from the today's lecture our participants learned a lot from today's wonderful lecture on role of science and technology for sustainable future, delivered by the Professor Doranjit Singh. Thank you again. And from the today's lecture, what we learn, what we summarize, the history of science and technology examines how humanity's understanding of science and technology has changed over the centuries. The 21st century is the century of science and technology. Today, we do almost all our work with the help of science and technology only. In modern items, the clean growth of country cannot be imagined without science and technology. We all know the value of science and technology in our daily lives, and different inventions of science have made our everyday life simple and stress-free as well. So on the other hand, technology has taught as the modern way of life. So from the today lecture, we learned these very clearly, how it is important in our daily lives. And on the other hand, economic growth of a country also depends on the growth of science and technology. So according to recent data, our country, India, has the third largest scientific workforce in the world. So India is progressively developing in the field of science and technology. So the Indian Space Research Organization, ISRO, has its own launch satellite among all the countries in the world. So after independence, India launched a number of satellites in space of its own efforts. So on November 5, 2013, India again proved its power in the field of science and technology by launching Mangalyaan on Mars. So we can say that how India progressed in the field of science and technology today. So the former Indian President APJ Abdul Kalam has worked himself out at DRDO and ISRO and trying to develop India in the field of science and technology. So with the advancement of this science and technology, some deadly weapons have been developed and modern wars of different nations have Gandhi University. Thank you very much.
Thank you. Thank you all.
Thank you, sir. Namaste.
Thank you, Dr. Jyoti.